Hi everyone, happy weekend. Welcome to another episode of my YouTube channel, Data Science with Sam. In today's video, I'll talk about deep learning, a term that's been very popular in recent years. Deep learning is a continuous part of artificial intelligence. This artificial intelligence concept kind of started back in 20th century. The main idea was to mimic human intelligence and behavioral pattern into machine. Then after that, it progressed into machine learning, which is a technique where we can actually make the system or computer work without being explicitly programmed on. So computer can work without manual supervision. But then after that, we found some kind of a limitation with machine learning that can be eradicated with a new concept. And here comes deep learning. So the idea of deep learning is kind of inspired by human brains. So because it has those neural networks, which kind of work like the neurons in the brains. So we kind of found that the deep learning could take us to the next level where it can harness the computational power. It can predict some of the algorithm with a better accuracy and maximum throughput. It can reduce the runtime. There are some complex algorithms we're not able to achieve by machine learning, but can be achieved by deep learning for sure. So let's check out in the next section, what's the main difference between machine learning and deep learning? So the obvious question is, what is the difference between deep learning and machine learning? Because as we all know that deep learning is nothing but a subset of machine learning. But there's got to be some difference. And the difference is feature extraction stage. So this feature extraction stage is very important in the conventional machine learning framework because we use that stage to extract the key features from the data set, we reduce the dimension, and then after that, we pass on those key features to classification or any regression algorithm for prediction purpose. Whereas in deep learning framework, we don't perform that stage explicitly. Rather, we combine that feature extraction phase with the classification model building phase and perform it dynamically. So we'll definitely reduce the overall runtime. And since we are using a neural network, we can perform a lot of forward propagation and back propagation in between that help us to extract more features from a data set. So the deep learning was is very beneficial for any kind of complex prediction algorithm because it can harness the better computational power and it can provide you better accuracy than a conventional machine learning framework. So in the previous section, I mentioned that how the elimination of feature extraction stage made the deep learning framework superior over conventional machine learning. Let's talk about some of the applications that have been developed on deep learning. Virtual assistant, Amazon Alexa, Siri, or Google Home developed on deep learning framework using IoT technologies. There are some retail companies use a chatbot, which is actually a deep learning application that performs as a virtual agent. Healthcare industry started using deep learning for drug discovery or any sort of medical diagnosis purpose. Entertainment industry also using deep learning to improve their video quality, use a lot of different video augmentation. Even the automobile industry, they're using this deep learning framework to build autonomous car that can predict image or object on runtime. So let's think about like Tesla's self-driven car. It can actually use deep learning to detect objects when it's driving on the street. There are other industries using computer vision, which is actually a byproduct of deep learning framework for image coloring and also eradicate some of the deep fake or fake news. It also using deep learning to make better prediction and also for their advertising purpose. Netflix, Amazon Prime, and some of the other streaming channels using deep learning to provide better movie recommendation. So next time when you go to Netflix, just wanted to get some recommendation, deep learning will help you out. So these are some of the applications that have been developed deep learning, and we're still using it. It's becoming a part of our household nowadays. So deep learning impacting your life. So that brings me to an end of this video, which gives you a brief overview of deep learning. It is imperative that deep learning has become an acquired knowledge of data scientists and machine learning engineers in today's world. As we progress further in this field of study, we need to know how we can improve our deep learning framework by adding more neural network, or maybe we can harness more computational power. So how do we achieve that? So we need to know how deep learning framework can be built from the scratch. So in my next video, I'll talk about the technical components of deep learning. I'll tell you how you can build a deep learning framework from the scratch. So stay tuned for that. And also, this is a series of deep learning that will continue for next couple of months, I guess, because there are a lot of things to talk about deep learning. So don't forget to subscribe to my vlogs because those videos will be very useful if you want to pursue your career in data science. So till then, goodbye and stay safe. Hi everyone. Welcome to another vlog edition of my YouTube channel, Data Science with Sam. This video is a continuation of the deep learning series that I started a couple of weeks back. In my previous video, I spoke about deep learning, like what is deep learning and how it differs from machine learning and how it's also revolutionized the field of artificial intelligence in last 1 decade. I spoke about there's some applicability of deep learning in different industries as such automobile, manufacturing, healthcare, and even in the entertainment industry. Now, if you want to apply deep learning for your data science work, how are you going to build a deep learning technique, right? So let's talk about the main building block of deep learning, which is nothing but neural network. The original idea of neural network was inspired by human brain. We know that from our biological class that neuron is one of the main components of human brain. And those neurons are connected by synapses and they carry out some activation function that help us to perform some biological activities in our body. So similarly, we have neurons in artificial neural network, and those neurons are responsible to carry out those computational functions that derive the prediction or any kind of classification model within that neural network. But the architecture of artificial neural network is less complicated in comparison to human brain. In artificial neural network, we dealt with 10,000 neurons, as opposed to in human brain, we have around 80 to 90 billions of neurons. So now let's see what are the main components of neural network in the next section. So the topology of neural network architecture is very simple, as it's mainly built upon 3 major components: input layer, hidden layer, and output layer. Input layer, as the name suggests, is mainly responsible to collect the input data and pass the data onto hidden layer. Hidden layer performs the main computation using the data. It also performs the feature extraction because without the main features, it will be difficult to perform the computation. Then after that, the computation results pass it on to output layer. So based on the classification exercise, whether it's a binary or multi-class, the output layer is segregated into different sections. Like if you're performing a binary classification exercise, your output layer will only have 2 classes. Let's think about a computer vision exercise where you're trying to detect an image of cat or dog in a data set, in a particular image. So in that case, you're trying to perform a binary classification. So your input layer will collect a combination of cat and dog images. It will pass those images to hidden layer. Hidden layer will collect the key features corresponds to cat and dog image and then perform a classification exercise. So once that classification, the actual classification computation will get done, it passes that results to output layer. And output layer will denote that result in a form of 2 classes. And one class corresponds to cat and another class will correspond to dog. So that's how neural network usually perform classification exercise using these 3 major components. Now hidden layer has 2 different sections. It has forward propagation and backward propagation. So which usually responsible to perform the main computation combinedly. Now let's check out in the next section how these 2 propagation techniques carry out the main process within the hidden layer. In previous section, I talked about 3 important components of neural network: input layer, hidden layer, and output layer. Now let's talk about how these 3 layers correlated with forward propagation and backward propagation technique, which help the neural network to learn the data and predict accordingly. In the forward propagation stage, it's trying to make a guess of the answer, means the actual prediction happens here. So first, it randomly initializes weights W1, W2, W3. It multiplies those weights with the X1 and X2 input data to form the hidden layer, which is denotes here like H1, H2, H3. So these are the 3 hidden layer data points. Now, after that, hidden layer perform the final computation and provide the results to an activation function. So this activation function will assess the results, and based on the results, it's calculate the probability score, and the final results is come as a probability percentage. Like suppose if you're performing cat versus dog binary classification, then activation function will be responsible to segregate the classes based on the probability score and provide the output at the layer accordingly. So now in the forward propagation section, you must be wondering that when we are calculating the weights and we're calculating the hidden layers based on multiple random weights and input data, so what's the possibility that the randomly initialized weights are accurate and it can perform a better prediction with higher accuracy? It's not possible to determine that at the early stage. And that's why we need to perform backward propagation, where we need to find out what's the minimized error rate, because in most of the cases when you perform forward propagation in the hidden layer, the actual guessed output deviates from the actual output. Like for example, like if you're trying to calculate a certain classification exercise, it's possible that your expected probability score does not match with the observed probability score. So in that case, your neural network ends up having some errors. So backward propagation helps us to minimize that error. And how it does, it basically calculates the expected value and observed value using a loss function, and then they perform a derivative of that errors for different weight and pass it to the initial weights. So actually in the backward propagation, we continuously update the weights by calculating the derivative of the errors. So eventually it helps those weights to find out the optimal parameter, optimal value, which will minimize the loss function and the error rate. So once this backward propagation done simultaneously with forward propagation, it eventually reduces the error rate and help neural network to predict with a better expected value, observed value. So once the expected value and observed value matches, or at least it comes close to each other, then backward propagation step stops. So when backward propagation stops, then the forward propagation techniques triggers the activation function, which provide the final probability results at output layer. So that's how forward propagation and backward propagation execute simultaneously or concurrently sometimes to perform the final computation in the neural network. So now let's move on to the next section to conclude this video. So today's video covers a very important aspect of neural network. You learn the basic components of neural network. You also understand how forward propagation and backward propagation works. So those two propagation techniques are the main driving factor of the actual computation happens within the architecture. But that's not the end of the show, because if you want to learn neural network architecture development, you also need to understand how you can manually select the hyperparameters, which can make your model less erroneous with a better prediction rate and less time consuming. So how you can achieve that? So I'll cover that in my next video, where you'll get an idea of those hyperparameters that you need to select during model building phase. So neural network model hyperparameter selection is coming in my next video. So stay tuned for that. Also, please don't forget to like and subscribe to my channel, because more contents are forthcoming. I'll talk about neural network and some other aspects of artificial intelligence in the next few months. Also, please look down at the captions as I shared some of the learning materials that will give you a comprehensive overview of deep learning and neural network architecture. So stay tuned. Till then, goodbye. Hello, everyone. Welcome to another episode of my YouTube channel, Data Science with Sam. This video will cover another exciting topic on neural network. As you remember, in my previous video, I spoke about neural network components. There are three major components such as input layer, hidden layer, and output layer are kind of like a main building blocks of neural network. And I also covered forward propagation and backward propagation techniques in my previous video. Now you know how these two propagation techniques played crucial role to make your neural network learn the training data. Now, when you train your neural network using these two propagation techniques, you must be wondering that do we have to provide any manual intervention? Because as we know, in neural network, the feature extraction process happens automatically. But still, we need to pass some parameters into a neural network so the model will understand the data better, it can minimize the loss, and it will improve the performance and provide better prediction. So in today's video, I'll talk about those hyperparameters only. So in next time when you build your neural network, you will know which are all the main hyperparameters you need to pass to your model. But before proceeding further, I would definitely recommend you to go back to my YouTube channel and watch the previous video because there are certain stuff you won't be able to understand if you never know about what is input layer, hidden layer, output layer. So I would definitely recommend to go back, watch that video before you go to the next section. And don't forget to smash the like button and subscribe to my channel because there are more exciting data science related videos are forthcoming, and we'll also get to know about how you can build your neural network using PyTorch and TensorFlow in my upcoming videos. So please subscribe to my channel and let's go to the next section to learn about hyperparameters. So as you all know that neural network performs feature extraction process automatically, but there are still some parameters that we need to pass manually during model building phase. For example, learning rate is one of the most crucial hyperparameters that we need to pass through neural network model because that learning rate will decide how your neural network will perform on the trained data, like the data we're actually passing it through input layer. But there are two caveats. If your learning rate is very small, your model will take enormous time to train on the input data and provide prediction accordingly. On the contrary, if your learning rate is too big, then your model will jump to conclusion, which will lead to a very bad prediction. So finding an optimal learning rate which can improve your model is a very challenging task. But we got to actually follow some trial and error approach to find out the optimal learning rate that will help improve the performance of your neural network model. So always watch out for learning rate because that could be a game changer for your neural network model. So let's move to the next section to learn about more hyperparameters. Another important hyperparameter is activation function, which is responsible for empowering neural network because it helps neural network to decide on which neuron will be activated for prediction purpose. So if neural network won't use activation function, it will adversely impact the model performance. So think about activation function as a funnel. Okay, so it will basically filter the main neuron with the main key features, and those key features will be responsible for performing the prediction in the later stage. So now this neural network activation function is usually a kind of a nonlinear function, and it also increases the degree of freedom of the learners. It's also enabled the model to perform better and also make it stable and generalized more on a different unseen data. So it actually helps to improve the accuracy. So there are some activation functions which you use for our neural network model building phase, such as ReLU, which is we call it a rectified linear network. And also we use sigmoid function. So sometimes we use Gaussian function as activation. But if you consider the popularity, we mostly use ReLU and sigmoid as activation function for any such neural network. We will talk about it more in my next videos when I will give you a hands-on experience of how we can build a neural network from the scratch. So next, move on to the next section for another hyperparameter. Another important hyperparameter is cost function because it used to calculate loss given the real and observed results. Let's think about the backward propagation technique that I mentioned to you in my previous video. So during backward propagation technique, neural network model try to minimize the loss during the training phase. Now, how it determines the loss means the difference between the expected output and the actual output. Well, cost function helps neural network to make that calculation. Without cost function, it's difficult to understand that how accurately your model is performing. Most of the cases, cost function integrated with an optimizer to help perform the calculation during the neural network training phase. Some famous cost functions are quadratic cost, which is related to root mean square, a very popular statistical measure. One of my favorite statistical measure or the cost function is cross entropy, which usually I integrate with either Adam or SGD optimizer. So most of the cases, a cross entropy cost function can be differentiated based on how many classes you're trying to predict. So if you're trying to predict like a binary classification model, so in that case you use binary cross entropy. But if you're trying to perform a multi-class classification exercise, then use I think categorical cross entropy. There's another important cost function that's kind of becoming popular recently. It's called exponential cost function that you can use with AdaBoost optimizer. So AdaBoost optimizer are actually one of the best performing optimizer right now because it seems like in certain cases it performs better than SGD and Adam. So in most of the cases, actually data scientists are considering it as a combination of SGD and Adam right now. In one of my videos in next few weeks, I'll talk about optimizer because that's also a very important aspect of neural network model. In most of the cases, I personally prefer SGD and Adam, but check out this AdaBoost because that optimizer is becoming very popular in recent days. Now let's move on to the conclusion section to wrap up this video. So today's video covered a very brief overview of hyperparameters, but at least it gives an idea that what are the parameters you need to select manually for your neural network model. And also there's one more hyperparameters that I need to share is called epochs or iterations, because you need to train your neural network for certain iteration to get a better results. So finding epochs or iteration count is also a very good approach because it's sometimes in some cases some models perform better if you use a smaller number of epochs, but in some cases you may have to go for a larger number to get better accuracy. So epochs or iteration is also very important hyperparameters, so don't forget about that. So now you must be wondering that you learned neural network components, you learned about hyperparameters. So what's next? So now I need to give you a hands-on experience of how to build a neural network model from the scratch. So I'll cover that in my next video. And I'll basically start with the convolutional neural network model, which is most popular and most applicable in real world. So stay tuned for that. And also just look down in the caption section because I provided some learning materials that will give you more idea about neural network hyperparameters. So now let's wait for the next video. And also please try to learn more about neural networks because that will be helpful for your data science work in future, because deep learning has a long way to go. Okay, because we just taking a baby step in that, and there's so many things we can explore using deep learning. So stay tuned. Till then, goodbye. And don't forget to like and subscribe to my channel because more videos are coming. Hello everyone. Welcome to another exciting video of my YouTube channel, Data Science with Sam. So this episode is a continuation of my deep learning series that started a month back. In my previous videos, I talked about neural network, the basic building block of deep learning world. I also spoke about how neural network mimicked human brain with a combination of different neurons in 3 different layers, such as input layer, hidden layer, and output layer. I also give you a brief explanation of the model hyperparameters that you need to select during your neural network model building phase. So I'll definitely encourage you to go back to those videos, watch it one more time before you proceed further. And also don't forget to smash the like button and subscribe to my channel as more videos related to deep learning, machine learning, and data science are forthcoming. Now, in today's video, I'll talk about a very widely popular neural network. Can you guess it? Well, it's convolutional neural network, which played a pivotal role in the computer vision world because it helps you to identify objects in a far distance. It helps you to classify different objects in a particular static image. Also, it helps you to detect something in a running video. like Tesla autonomous car, like how they usually detect objects when they're moving on the street. Well, they use kind of like a very complicated CNN architecture, but I'm not going to teach you that now, but I'll definitely tell you a very basic CNN architecture that you can use for your data science work. And then you can keep building on it and you can improvise that for any kind of computer vision work. So let's check out in the next section how you can build a very basic CNN architecture from scratch. So the fundamental concept of convolutional neural network or CNN architecture is based on neural network components that I discussed in one of my previous videos. The convolutional neural network also based on the similar components such as input layer, hidden layer, and output layer to process the image and provide classification results accordingly. In addition to those layers, it also has some layers such as convolutional layer, maximum layer. It will help us to extract the feature, provide the feature map, and pass it on to hidden layer accordingly. Now, let's check out this architecture that gives you a thorough rundown of how convolutional neural network architecture looks like in reality. So as you can see on the left side of the screen, the input image, which is nothing but an RGB image of a cat. So what is RGB? RGB is nothing but it's a red, green, blue image. The most of our images are RGB. And apart from that, sometimes we also deal with grayscale image. So what's the actual matrix representation of the image? Because that's exactly what we deal with in the neuron. So in the actual matrix representation of this input image is 2 to 4 by 2 to 4 by 3. So that means that this image is a resolution of 2 to 4 and it actually has an RGB channel as it corresponds to parameter 3. So once we pass this image to our first convolutional layer, let's see what happens. So in the first convolutional layer, what it does, it processes the image and extract all the features. So we use a talk technique called kernel to extract the feature from the image. So kernel is more of like a filter, and what it does, the filter usually calculates dot product with the matrix representation of the input image, and that helps to extract all the feature and pass it on to the next layer. So while kernel is extracting the feature from an image, there is another technique called padding that determines that the amount of pixel that will be passed on to the next layer. So with the combination of kernel and padding, convolutional layer extract all the feature from the image. There is another technique called stride that helps us determine that how many steps the image will move forward. So in most of the cases, the stride value is 1. So the reason we have a default value 1 because usually in a convolutional neural network architecture, the image processes one step at a time. So from one layer to another layer, that's how it processes. Now, after we get done with the first convolutional layer, you can see, you want to see the output dimension. So in CNN architecture, we call it as feature map. So the feature map is nothing but the output dimension of the convolutional layer as it denotes here. And as you can see, there is no change in the actual image resolution because it stays the same, 2 to 4 into 2 to 4. But the channel, that parameter is kind of like flexible because there is no such, I would say, rule of thumb that you have to keep the same channel value while you're processing through the convolutional neural network. You can definitely change it. So that's why this channel value is more of like a variable number. So based on the channel value, you can actually calculate the final nodes or neuron counts. So now this is the final kind of like feature map from the first convolutional layer. Now let's move on to the next section. So then the next layer, you will see there is a thing called max pool layer. So the reason we use max pool layer because the combination of neurons should not overburden our architecture. We have to keep our image resolution or the feature map minimal so that our CNN architecture can process the image in quicker time with the improved accuracy. So in order to do that, sometimes we have to go through a trial and error approach to find out what's the optimal number of max pool layer. So what max pool layer does, it just downsample the image resolution. As you can see in the second layer, we have 4 by 4 max pool layer. So what it's doing right now, it's downsampling the image, the actual feature map coming out of this convolutional layer to 16 by 16 into channel. It's just a division. Okay, so it's like what it does is like dividing 2 to 4 by 4, and then it processes the feature map accordingly. So once you get done with this max pool layer, so you have another kind of improved feature map with a lower image resolution, but it has all the key features intact. Because one of the main aspects of max pool layer is to shrink the image, the feature map, but it will capture the main key features which will be passed in the further layers to calculate the main computation. Now, once you're done with the first max pool layer, now it's your choice whether you want to include another convolutional layer to improve the accuracy or build a more robust architecture. But here I'm just giving a simple overview of that architecture. So I did not include any other convolutional layer, but you can definitely include another convolutional layer architecture to make your architecture maybe more robust, but it will become more complicated. So, so as I said before, there is no rule of thumb here. You just kind of like have to perform trial and error approach. You are entitled to add as many as convolutional and max pool layer to your architecture as long as it gives you a better accuracy. So in this neural network, in a simple one, I introduce another max pool layer to downgrade the sample feature map to 8 by 8 and channel. So once I downgrade it to this to feature map, so now what I'm going to do that this particular feature map will be flattened and pass it on to the linear network. Because before that, we are only talking about the convolutional layer where we kind of follow the non-linearity concept. But when we pass the non-linearity concept feature map to an activation function, we have to make sure that the feature map is flattened before you pass to the actual linear layer. So what a linear layer is doing here is basically getting all the feature map value from the convolutional layers or from the last layers, whether it's max pool or convolutional, and pass it on to this hidden layer. So in the hidden layer section, we sometimes we perform activation function before the hidden layer or in between the hidden layer, or sometimes we do it after the hidden layer. So in general cases, the best practice is to use two linear layers. Okay, so you actually get the data, get the feature map from convolutional layer, pass it on to first neural network, linear layer, and once the first linear layer will complete the calculation, then it will proceed to the next one. But here I'm just showing you just one linear layer, and that linear layer will also coincide with the ReLU activation and a dropout layer function. So now what this ReLU activation does. So obviously ReLU activation will determine that how activation will be performed, how the actual feature map will be translated into the main output layer. So once we perform the ReLU activation, then we also introduce this dropout layer, because in some cases we've seen some data overfitting issues in the CNN architecture. So to avoid the data overfitting, we introduce another layer called dropout layer before we publish the final feature map or the results to output layer. So in the output layer, as you can see, there's two circles on the right side. The reason I mentioned two circles here, because in this CNN architecture, it classifies two things. Okay, it classifies whether an image is a cat or dog. So that means we're dealing with two classes. So based on our final class values, the final feature map will shape like that. So final feature map is nothing but the total number of nodes, means it's a combination of all the final feature map and multiplied by the number of classes. So in some cases, what happens that your final class will be either 2 or 3 or how many predict outcomes you want. Okay, like in this case, you are just we're just dealing with like two classes, whether an image is cat or dog. It's like more of like a binary classification. So that's why the final feature map will hold only value 2 for the number of classes representation. So that's it in a nutshell. So that's kind of like a basic CNN architecture, that how the image actually process through convolutional layer, and then it goes to a series of maxpool layer to downgrade the actual feature map. Then after that, the flattened feature map pass it on to the fully connected linear layers. It also perform the ReLU activation function inside the linear layer before publish the final results in as a form of like two classes. So that's the actual representation of our main CNN architecture. Now let's move on to the next section to conclude this video. So today's video gives you an idea of how you can build a convolutional neural network from the scratch. So we need to use the term CNN most repeatedly because that's kind of like a most popular term. Not the CNN news channel, but CNN means I'm talking about the deep learning CNN. So now you need to understand that how you can code a CNN network, because what I just gave you is just more of like a hypothetical overview of the architecture, but you need to understand how we can actually code it, right? So let me tell you that I have a session coming up that will give you an overview of how you can build a CNN architecture using PyTorch and TensorFlow, one of the most two popular machine learning libraries that have been used to develop CNN architecture in recent days. In computer vision world, people use both these libraries, and I don't have any preference, but obviously I have knowledge in working in both those libraries. So I'll definitely share my experience with you. So let's wait for my next video where I can share you how to develop a CNN architecture using PyTorch or TensorFlow. It will also give an idea about what's the pros and cons of these two libraries. So let's watch out for that video. It's coming soon. And don't forget to like and subscribe to my channel. Otherwise, you will miss out all these exciting videos on deep learning and neural network. So till then, goodbye. Hello, everyone. Welcome to another exciting vlog of my YouTube channel, Data Science with Sam. This vlog is a continuation of the series on deep learning that I started a month back. In my previous vlogs of this series, I talked about what is deep learning, what are the main components of neural network, what are the key model hyperparameters that will select for your neural network model building phase. I also talked about a very widely popular neural network, which is called convolutional neural network in my previous vlog. So I also, give you a picture of like how you can use a CNN model for image classification purpose. So if you missed out any of those vlogs, I'll definitely encourage you to go back to my YouTube channel and watch those videos before you proceed on this one. Now, after you got an idea about how to build a neural network, the next step would be to get a hands-on experience. So in today's video, I'll talk about two machine learning libraries, PyTorch and TensorFlow, that will help you to build a neural network model from the scratch. So now what is TensorFlow? So TensorFlow was developed by Google and released as open source software in 2015. It grew out of like Google's homegrown library, which was kind of refactored and optimized for production purpose. And when TensorFlow got released in 2015, that time it was one of the main machine learning library people are using to build neural network model. Then the situation got changed in 2016 when Facebook released their open source library, PyTorch. So as soon as Facebook released the PyTorch, it started gaining popularity because for Python programmers, they found it easier to use PyTorch than TensorFlow. So that's kind of pushed TensorFlow a little behind in that competition. So eventually TensorFlow came back with a different version 2.0 in 2019, and that helped them to gain a little bit of popularity. So the 2.0 actually had a less features. You have to write less code to get done with the numerical operation on data. But however, both the libraries have tons of features to integrate with the different APIs. I mean, they can run on different cloud platforms. So, I mean, in reality, you can use both the softwares, both the libraries, based on whichever you are comfortable with. So now let's find out what are the main differences of these two machine learning libraries. So let's check out in the next section, and don't forget to like this video and subscribe to my channel because more exciting vlogs on PyTorch, TensorFlow and other machine learning libraries are forthcoming, and you get a more hands-on experience on how you can write code to build your neural network model from the scratch. Okay, so let's go to the next section to find out what are the key differences between these two libraries. Now let's talk about the key differences between PyTorch and TensorFlow. So first one, TensorFlow works on a static graph concept. That means the user first has to define the computation graph of the model. But for PyTorch, it believes in a dynamic graph. So everything happens on the go. The next one is in TensorFlow, the user actually has to define the debugger function, whether it's TF debugger or some any other variables. It needs to explicitly has to be selected for debugging function. But for PyTorch, the user does not require any sort of learning mechanism to make the debugger work. In terms of coverage, TensorFlow supports higher level of functionalities, whereas for PyTorch, it actually has very fewer features. When it comes to integration of NumPy, so PyTorch is more capable of using the NumPy functions. So a lot of Python programmers find it very easy to use PyTorch because they can easily incorporate all the NumPy functions for numerical operations. But it's kind of difficult to incorporate similar kind of NumPy numerical operators for in TensorFlow. So that's why usually in the beginning, PyTorch started gaining popularity because of its capability of integrating with popular Python libraries for numerical operations. The next difference is, so a lot of coding languages could be integrated easily with TensorFlow, like C++ and Java API could be easily executable on the TensorFlow platform. But PyTorch has a limited capability to integrate with other programming language. In terms of configuration setting, for TensorFlow, a user does not require to specify anything since the default configuration settings are already set in the machine library platform or environment. Whereas for PyTorch, the user needs to explicitly set the CPU capacity or a device capacity if they have the pseudo is enabled explicitly. So if for PyTorch, if a user use that pseudo functionality, so in that case, they have to explicitly mention the configuration setting. But for TensorFlow, everything has been set default, which is also kind of difficult. So if you want to enhance the capacity of your cloud platform, so and if you want to, if you want your TensorFlow library to harness the maximum throughput from your cloud environment, it's difficult to scale that functionality in TensorFlow. Whereas for PyTorch, it's easy to make it scalable and so that it can harness the maximum power of the cloud environment where you're running your machine learning function. So that's all. So these are the main differences of PyTorch and TensorFlow. Now let's check out that how you can perform a simple numerical operation like multiplication function using these two programming machine learning library. The basic data structure of TensorFlow and PyTorch is nothing but tensor. But so how you perform the numerical operation on tensor using these two libraries? So they have a little different operation practice when you perform any sort of like a multiplication, subtraction, or division numerical on that tensor. So let's find out. So as you can see on the left side, it's giving you a programming example of how you can perform a numerical operation such as multiplication on two tensors. For example, here what you're doing is you're importing the TensorFlow object first from the TensorFlow library. Then you're defining x and y variables or tensors in a form of list. And then after that, you are using TensorFlow's inbuilt multiply function to perform that numerical operation. And then you produce the output. Whereas in PyTorch, if you see here, we are importing the torch library first, as well as we are also importing the NumPy feature. The reason actually we are importing the NumPy feature because in certain case, we may have to convert our tensor object into a NumPy feature, so it could be easily integrated with other Python functionalities. So like here, what we are doing in PyTorch, we're converting the x and y into a NumPy. We're actually forming the NumPy array using the NumPy feature. Then after that, we are using torch multiple functions to perform the element-wise multiplication. So here, before we perform the multiplication, we also need to ensure that we are converting the NumPy object into torch object before we apply that function. The reason we have to do that because the torch, any sort of torch functionality usually won't work on NumPy object. So in that scenario, we have to basically convert the NumPy object into torch functionality before you perform any sort of numerical operation. However, after you get done with the after you get done with the operation, you have this output record stored in M. So M is more of like a torch object. So now if you don't want to produce output in a form of a tensor or torch object, what you can do is that you can convert into a NumPy format using m.numpy function, and your output will look like this. So you can see that even if the values are same, but the output is different in between TensorFlow and PyTorch. In TensorFlow, it's the output is being produced as a tensor object, whereas for PyTorch, you can transform the torch object into a NumPy. So that's kind of like an advantage of using PyTorch, as you can easily convert a tensor object into a NumPy for any sort of numerical operation. But TensorFlow does not have that capacity, as it is not compatible with NumPy library. So which is why, I mean, a lot of Python programmers also started using PyTorch since 2016. And a lot of cases, I mean, even if TensorFlow and PyTorch both are being used in academic research and in commercial purpose, in recent days, I think academic researchers are using PyTorch more than they're using TensorFlow for building either neural network model or any sort of deep learning exercise. So this video gives a very brief overview on the key differences between PyTorch and TensorFlow. So based on your data science project work, you can choose either of those two libraries. Sometimes TensorFlow would be a good bet if you want to deploy your model on mobile devices, because you can easily integrate TensorFlow library with other APIs. But if you are a very good Python programmer, then I would definitely recommend you to use PyTorch, because there are a lot of Python libraries which are compatible with PyTorch functionality. But also in terms of cloud environment, TensorFlow can be easily integrated with Google Cloud, whereas PyTorch has some features or some capability on AWS. There is a feature called Torch Serve, which you can use to build your PyTorch model on AWS. So just do a little bit of research on that and decide which library will be suitable for your neural network model building work. In my next vlog, I'll actually talk about how you can build a CNN model using PyTorch and TensorFlow, because that's very important for you to know that how you can build a convolutional layer or even a max-pool layer, or you can just tweak your linear layer in order to improve the accuracy. So that will be covered in my next vlog, so stay tuned for that. And also, please like and subscribe to my channel, because more videos are forthcoming. And also, please share your comments over here. Let me know how, if you have any comments or suggestions on my data science vlogs. If you want me to cover any more data science related topics, please feel free to share your comments. So I'll definitely include them in my next vlogs. So that's all for now. And please go through all the learning materials that I shared in that captions. And again, don't forget to watch my videos. And till then, goodbye. Hey everyone, welcome to another episode of my YouTube channel, Data Science with Sam. This vlog is a continuation of the computer vision series that I started a couple of months back. In my previous vlog, I talked about image classification. I showed you how you can build your first image classification model using neural network technique, and also classify images of cat and dog. If you missed that vlog, then I'll definitely recommend you to go back to my channel and watch that vlog before you move further with this one. In today's vlog, I'll talk about face detection, another very important computer vision technique that we are using in the industry world. Now let's move to the next section to see how this face detection actually works and how it differs from the face recognition mechanism. Face detection kind of gives the computer the ability to detect anything other than nothing. For example, when you are seeing an image, that image might have like 2 to 3 different faces. So how computer can detect those faces within that image? So face detection will help in that aspect. Now, how does it differ from face recognition? But for face recognition, it's not only detects the faces within the image, it also tells the user that what particular face that is. It gives an identity to that particular face within that image. Now, for face detection, it's identify the presence of people faces within digital image. So in order to work that, so face detection application use different sort of machine learning models or formulas known as algorithm to detect that human face with larger images. So it doesn't matter how many faces are there within an image, it should be able to detect all the faces as long as they belong to human class, or as long as the model or the algorithm has been trained to detect human faces. And the rest, on the other side, for face recognition, it basically describes a kind of like a biometric technology, as it not only gives computer the ability to detect face within images, but it also attempts to establish whose face it is. For example, like if we upload a picture to Facebook, Facebook sometimes gives a suggestion to tag a particular person in that image. So how Facebook model would determine, because the Facebook model already recognized that face using its face recognition model. So that gives Facebook a kind of like an ability to provide a suggestion that, okay, so this person might be there in that image. So please tag him or her in the image. So that's how the face recognition model works within that Facebook system. Now, the next thing is that what kind of popular model we use in order to perform face detection or recognition. So there are plenty of libraries that are available in Python, like OpenCV, FaceNet, MTCNN, or even face recognition models that you can use to build your first face recognition detection model for classification purpose. And when I'm talking about classification, it basically classifying whether any human faces are existed within images and what particular face that is. Now, you must be wondering that how computer performs that underlying face recognition algorithm. So the way it actually happens is, first algorithm try to understand a similarity between faces. Like for example, if you pass these two faces into your face recognition algorithm, what it does that it tries to transform those image features into an embedding vectors like this. So both these images are different. So they have a different embedding vectors. And then after that, they consolidate both the embedding vectors together and apply logistic regression on top of that. Now, if those two images are same, then the embedding vector should provide an output in the form of binary 1. But if the pictures are not same, the images are not same or belong to a same person, then it will give you an output in the form of 0. That means the computer basically perform binary classification to understand whether those images are similar or not. So that's one way computer vision model determine the face recognition approach, and also it determines whether the images belong to the same person or not. The second approach is triplet loss, where computer already use an image as benchmark. So in the computer vision term, we call it as an anchor image. Like this person's image is an anchor image over here. Now, then the computer would actually, the model would actually get two more images as input. So like this person, it's actually an image of the same person. So this is actually a positive image. And we also feed another image to the model, which doesn't belong to the same person. So computer usually have one anchor or baseline image, and we basically feed the model with two more images. One is a similar image, another one is the image of different person. So we call them a positive and negative image. So what it does is the underlying model tries to determine the distance between an anchor and a positive image. It calculates the distance between anchor and positive image, and it also calculates the distance between anchor and negative image. So in the theory, the square distance between anchor and positive image should be equal, should be like less than or equal to distance between anchor, square distance between anchor and negative image. So that satisfies the triplet loss theory, where the anchor and positive image should have minimal distance compared to their counterparts. And when computer would understand, when computer would find out that the difference distance between anchor and positive is minimal and it's less than the threshold, or it's less than the other pairs, then the computer recognize this positive image as the image of the same person who belongs to that anchor class. So that's like another approach that computer uses to determine that, to recognize a face, and also determine that that image does have any other faces that belongs to the same category, or those faces are already there in the computer database. So you need to make sure that your computer or your model should be trained with similar faces. Like your model should have these anchor images. Otherwise, it will be difficult for any computer vision model to perform face recognition. So you need to feed your model with anchor images, and then perform the face recognition against that anchor images. Okay, so let's move to the next section and see how this face detection or face recognition technology actually work within an application. Let me show you an example of how this face detection actually work in real time. So the primitive app I developed using Streamlit, which is kind of like a Python library that you can use for building application. I used OpenCV package, which is very essential to build any face recognition or detection model. So first, I'm going to upload a picture. So let me upload this picture of a famous soccer player, Zinedine Zidane. As you can see, the model was able to detect the face. It's also showing that there is only one image present in that particular image. So now you can see that, like, this is how the face detection works. It actually detects a face within an image. Now let me see how this recognition works. So now, as you can see, the recognition also worked here, as the computer was able to determine that this face belongs to a famous soccer player, Zinedine Zidane. So in order to achieve that, you need to make sure that your model has been trained with some anchor images which belong to Zinedine Zidane. So otherwise, it won't be able to determine whether this face belongs to Zinedine Zidane or somebody else. For example, like if I try to upload a picture from a different, like an image of different person, which was not being used during training time, then your model won't be able to detect them. So for example, I'm just randomly selecting someone from here. So let me just upload this Al Pacino's picture. As you can see that the computer was not able to determine this Al Pacino's picture. The main reason is because the model, the underlying model, hasn't been trained with Al Pacino's picture. That's why the computer was not able to recognize him. But if you want to do the face detection, it should be able to do that, because here it was not able to detect this face because it was not properly aligned on the image. It was literally cropped. That's why computer was not able to detect this face, but it was able to detect Al Pacino's face. So always remember that face detection is pretty easy. For face detection, you may not have to train, you don't have to train the model with a lot of images. It can definitely detect any faces without being trained by anchor images. But in order to perform face recognition, you have to train your model with anchor or baseline images. Okay, so for example, if I want to, if you want to make an app which can detect my face, I need to make sure that the underlying model should know some of my faces, should have some anchor images in order to understand that my facial feature are actually matches with the face recognition mechanism. So always remember that, and next time when you build your first face recognition model, always remember that the images that you're going to select should have an impact on your face recognition mechanism, but not on face detection. So that's all for now. Let's move to the next section to conclude this vlog. So that brings me to the end of this vlog. Hope you liked it. Hope this vlog gave an overview of how you can build your face detection model using neural network. I already shared the GitHub source code of that application that I already showed you. So please take a look at it over here in the video caption. And also please stay tuned for my next vlog on GAN, which is General Adversarial Network. It's also a very widely popular computer vision technique that's also emerging in the industry world at this moment. So let's check out that in my next vlog. And please don't forget to like and subscribe to my channel as more videos on artificial intelligence and computer visions are forthcoming. Till then, goodbye. Hey everyone, welcome to the fourth vlog of my computer vision series. In my previous vlog, I talked about object detection exercise. I also gave you a brief overview of YOLO model, which is a very widely popular model to perform object detection exercise in computer vision applications. If you missed that vlog, I'll definitely recommend you to go back to my channel and watch that vlog before you move further with this one. And please don't forget to like and subscribe to my channel as more contents on computer vision and data science are forthcoming. So in today's vlog, I'll talk about image classification. So what is image classification? So in a nutshell, image classification is a mechanism to categorize and label a group of pixels or vector in a static image based on specific rule. Like for example, in my previous vlog, I gave you an overview of how our autonomous car detects objects on the street. So how that autonomous car classify that object? How that computer vision or underlying computer vision model of that autonomous car identify that object belongs to a car, sedan car, or it belongs to a truck, or even it belongs to a traffic signal. So that kind of mechanism performed by image classification technique, which is nothing but an underlying neural network model that categorize an object based on specific set of features and their corresponding rules. So for example, like if you process an image through a neural network model, then it will extract all the features corresponding to that image, and it will memorize those features. So in future, if you try to predict another object, similar object using that same neural network model, then neural network model will classify that object belongs to that particular category. So in my next section, I'll show you that how a computer vision model classify an image belongs to a cat or dog based on certain features of their rules. Okay, so let's check out that how you can perform your first image classification exercise using a TensorFlow neural network model in order to identify a cat and a dog. In this section, I'll show you how you can perform an image classification exercise using binary mechanism on a dataset comprised of cat and dog. The neural network model that I'm going to build is going to classify an image and identify whether that image belongs to cat or dog. So at the first phase, I need to upload a data set comprised of cat and dog images. So I uploaded the images in a zip format to the temp directory of my Google Colab. In addition to that, I also have to import some libraries related to TensorFlow because those libraries will be useful to perform the image classification exercise in the later stage. After I upload the data set, I need to categorize the images into two different types. One set of images will be used for training purpose, and the other set of images will be used for validation purpose. So that part I'm performing over here. In addition to segregating the images into train and validation based directories, I do also have to make sure that in the train directories, I do have two subdirectories. One belongs to cats and one belongs to dogs images. So that means you actually have to split the images based on their labels. Like for example, if you print the 10 images from any specific directory, you would see that all the cat images starts with the label cat and the dog images start with the label dog. The reason we do that, perform this, the image processing, pre-processing in such a way so that a model would be able to identify the images easily and they can extract the features accordingly from any cat or dog image. The next step is to normalize the image, right? Because so when we perform any image classification exercise, we always need to remember that the any pixel range is between 0 to 255. So we have to normalize that image in order to make sure the pixel range falls between that 0 to 255 range. So we perform that using an image data generator function. The next step is we need to make sure that our image, all the images are following a standard size. So what we do is that we actually transform all the image into 150 to 150 target size. For your exam, for your exercise, you can change the target size. There is no rule of thumb over there. But for my case, I just transform all the images into a standard size of 150 by 150. Now you need to perform this image generator image transformation on both train and validation directory. So in order to make sure that all the images are of all the train and validation images follow a certain size and standard. As I mentioned previously, that here we're performing only two classification. The classification level is 2 over here because we are only identifying images based on 2 different categories, cat and dog. So that means we're performing binary classification here. In future, you may have to perform different kind of image classification where you have to categorize the images into multiple categories, like more than 2 categories. So in those cases, we usually call it as a multi-class classification. Now, if you want to visualize some of the images, you can run this particular program with the particular line of code, and it will show you the number of images. As you can see, there are tons of pictures of cats and dogs are lined up. So these are the images these are the images are going to be processed through the neural network model. Now, next, to talk about the model. So in this particular image articulation exercise, I'm going to use a regular sequential model. So this is so you can use a TensorFlow library to build that sequential model. The sequential model will have 1, 2, 3, 4 different convolutional network followed by a maximum layer. So the reason actually I'm using a combination of convolutional and maximum layer so that I can downsize or downsample the image size to certain level that when you are going to flatten that model finally, then you're not going to end up with a lot of nodes. So that's why I started with 32 input dimension, and slowly I increased that convolutional layer nodes, but also I make sure that I apply the maximum layer in order to downsample the dimension. So if you are a little confused about this convolutional layer architecture, I'll definitely recommend you to go back to my channel and look for a video where I talked about convolutional layer network architecture. So now after you flatten the convolutional layer, then you have to process all the images through a linear layer node. So here I used the activation function ReLU, and we actually have one linear layer, and the dense layer output would be 1. The reason the output is 1 over here because for this particular exercise, I'm performing 2 binary class. So it will be either a cat or dog, right? So in that case, your output layer should be comprised of one particular output dimension. Okay. So now the next thing, so once we finalize the model, so I'm going to run this model in order to make sure that the model has been processed. So now we have this model comprised of multi-layers of convolutional and maximum layers, followed by a dense layer. The next step is model hyperparameters. So we need to make sure that what kind of hyperparameters are we going to use for this particular exercise. So since it's a binary classification, that's why we use a loss function binary cross entropy. If you perform multi-class classification, then you have to use different kind of cross entropy function. For optimizer, I'm using RMS prop here, but you are entitled to use any other optimizers like SGD or Adam or any sort of other optimizers for your exercise. So I would definitely recommend you to try different optimizers and to make sure and optimizers and also learning rate to make sure that you find out the optimal the hyperparameters, which will provide the maximum accuracy from the model. The next step, I implement the callback function. The reason we have a callback function because no model is perfect, so it's very difficult to achieve 100% accuracy from any model. And we should not target to achieve 100% accuracy from any model. So here, but that doesn't mean that you're gonna let your model run for forever. So in that case, you need to set baseline model accuracy matrix. So here I'm actually setting up a baseline accuracy score, which is 0.9970. If our model would achieve that particular accuracy score during the training time, then it will stop right away. It will not process further. So that's why I implemented the callback function. So it will eventually it will reduce some model training time. So the next step is run the model. Now this process will take some time. So here actually I asked the model to run for like 50 iterations or epochs. So in some cases, since I already implemented the callback function, it's possible that a model would stop training after it achieves that accuracy, the baseline accuracy score that is set in the callback function. So as you can see, that first iteration been completed and the model loss is 0.6671, accuracy is 0.5420. We definitely expect that this accuracy will go up in further epoch runs and loss count will decrease gradually. As you can see that all the epochs taking like 9 to 10 seconds, so it's very fast. And so many times it will take enormous time for model to process the train during training time. And most of the time the model training time increased depends upon the number of images persisted in the data set. If you are dealing with like thousands of images for training the model, then obviously your model will not be able to train faster. And so many times you have to use a different configuration. Like for example, like for this particular exercise, I'm using a hardware accelerator as GPU. So I'm using actually GPU hardware accelerator. But if you are planning to like gradually increase, planning to increase your image data set, image volumes, then in that case, you may have to use kind of higher hardware accelerator like GPU, or you have to perform your exercise on Google Colab Pro, which provides better system configuration than the regular version of Google Colab. As you can see that the epoch run is progressing pretty well. And as you can see, the accuracy is going up. It started from 0.5420, now it's gradually going up. Now it's like 0.8470. So it's not very further away to meet that baseline accuracy score that is set in the callback function. And as you can see, as that accuracy score is going up, the loss is also going down. So this one is so this particular accuracy loss belongs to the training image. Now, if you want to check how the valuation loss and accuracy look like, so here you can see the valuation accuracy started from 0.5980, and it also gradually increasing, not at the same rate as the training accuracy, but it also increasing rapidly. So that means the model is training well. And also one more thing you need to make sure, when I mentioned the fact that sometimes you have to set the baseline accuracy score to a certain level, you can't expect that the model should accurately fit and it will yield accuracy 100%. But if it does, then that means sometimes model is overfitting. It's like because so many times it happens the data is exactly fit to the training model, the training data exactly fit to the model, which eventually lead us to a model overfitting issue. But in that case, the model failed to categorize any object on the unseen test data. So the model overfitting is a big issue. I'll talk about the model overfitting in one of my forthcoming vlogs, but always make sure that your model won't reach that 100% accuracy. But most of the time, if you achieve 100% accuracy, that means your model is overfitting against the training data. So as you can see, almost there. Right now our training accuracy is around 98%. So hopefully it will run for a few more epochs before it meets that validation accuracy, baseline validation accuracy. And if you see, on the other hand, the validation accuracy, it's growing, it's kind of like it's increasing, but it's not increasing at the same rate as turing accuracy. It's possible because most of the cases, the validation accuracy is, it's considered as an unseen test data. So you can't expect the validation accuracy would go up a lot. Okay, but in some cases, you can definitely tweak the model and see if you can get better validation accuracy. So as you can see that it's going pretty well, and it's almost reaching that stage. All right. So as you can see that the callback function worked as the model stopped training after 33rd epoch. So that means if the model reach that baseline validation accuracy, it will stop training, which is why we implemented I implemented the callback function at the beginning. Now let's see how this validation loss, validation accuracy will look like as opposed to training loss and training accuracy. So this is a training and validation accuracy plot. As you can see, the training plot is steadily increasing, but after a certain epoch, it kind of being stagnant because it's almost getting close to that baseline validation test accuracy. Whereas the validation accuracy remain kind of same within that around 75% zone. So if we can you can check that if we can tweak the model in order to improve the validation accuracy. But right now, a 75 to 80% validation accuracy, it's well enough to meet some sort of baseline metrics. Now, the next is training loss. As you can see, the training loss is kind of gradually decreasing. But the problem over here is the validation loss. You can see the validation loss is increasing quite rapidly, which is not a good sign. So that means the model is not performing well on the unseen test data. So how would you eradicate this kind of pitfalls? So in that case, there is a technique called image augmentation, which you can apply to your model, which you can apply to the training images before you process it through the model. So image augmentation would help you to alleviate some of these in the validation loss issues. So the validation loss, increasing validation loss is not a good sign for a model to perform well in the real world. Now, the next thing is let's test this model. Okay, so I'm gonna choose a cat or dog images and see if this model would be able to identify those images perfectly. So I'm going to process a cat image first. So I just uploaded a cat image, and as you can see, that model is able to identify the image as cat. Let's check out another one. So now I'm going to upload a dog image. There you go. As you can see, the model was able to identify the dog image perfectly fine. So that's all for now. So as you can see, this is a very primitive image classification exercise where it just kind of processes the model using a set of cat and dog images and make it understand that how it can identify an image cat and a dog separately. So that's all for now. I will definitely recommend you to check the video caption where I shared the GitHub link of the source code, and feel free to ask me any question. Feel free to share your comments in the video caption. So I'll be happy to answer. And I'll definitely recommend you to perform similar sort of image classification exercise using different image datasets. There are tons of dataset out there. Just download an image dataset from Kaggle and just do your own image classification work. So that's all for today. I'll definitely recommend you to check the Jupyter notebook in my GitHub account and also try to implement the same model using different data set. You're allowed to change the model. You can add more convolution layer or edit the current layers as well. You can always tweak the model hyperparameters and also apply data augmentation technique in order to improve the validation accuracy. There is no rule of thumb over there. You can always try different trial and error approach in order to come up with the best model. And always make sure that you have ample number of images to process through the neural network model. In my next video, I'll talk about another very important computer vision technique called face detection. So stay tuned for that. And please don't forget to like and subscribe to my channel as more contents are forthcoming. So till then, goodbye.